Warning topic for today is called abstract classes and interfaces. But besides that, I will tell you more details about other things, keyword final and nested classes, and hopefully these topics will not be too complicated to you. So first about keyword final to warm you up. Why it's called final and not something like const? Because meaning of it is different depending where it is added. And if you add final keyword in declaration of the class, it cannot be extended. And question might arise, why do you forbid classes for extension? And you forbid classes for extension every time you care about security and proper execution. For example, if you have some class which has method or some class which is some kind of validator, and this validator validates some data, either XML or YAML or username and password, etc. etc. And this class can be used as a library, so you put some jar file in your project, import it and use it. Then everybody who is not lazy might extend this validator in a such way that, for example, it always tells that these data structures are valid, and that may be something what you do not want to happen. And for such kind of classes, you add this final keyword in class declaration, and it cannot be extended, so its behavior cannot be overridden. Instead of entire class, you can add final keyword in method declaration, then you can extend class, but particular method cannot be overridden. So it's more elastic. You still may extend this class and add something new, but some of these methods which you care about, that they always work as it is intended to work, still will not be allowed to be extended. And final variable cannot be reinitialized. And here important part is that if this variable is primitive type, then actually it means that this variable is constant, because that means that you cannot change it later, because only way how you can change value of primitive type is to reassign it. For example, and then you say is 5, and then you say is 6, and you get compilation error. So, and if you do everything at once, then it is now constant. But for more complicated types, like the easiest thing which is more complicated than primitive type in this case is array. and you cannot reinitialize it. So you get compilation error here, but you still can change it, because you can say, for example, put in this cell this value, and then put in this cell that value, and then put in this cell this value, and put in this cell that value. So for more complicated things, objects, you cannot reinitialize them, and in this case this means you are not allowed to change size of array, but if it has more complicated internal structure, you still may change something into this final variable, and that's why it's not called constant, because of course here you see that values inside this array are not constant. And when you need sometimes something like global constants in other programming language like Pascal and Basic, then you usually call these variables with these modifiers public, static, final. Public means everybody can see it. Static means it is prepared together with loading of the class definition inside virtual machine. Final means you cannot reassign it or reinitialize it. And then type, name, and some value. That's how something like global constant looks like in Java. And then you can also use final keyword not in some local variables, but for these instance variables which do not belong to the class but belong to each particular object. For example, you can add final to some of properties of this object, and then when you create this object, you can initialize this particular value once during creation, during construction of this object. But then when you have assigned this particular value, then you are not allowed to reassign it, and this is one of approaches you can use, for example, to be sure that some primary key, which should be unique for these objects, never changes during lifetime of your object. For example, in our example about traffic management system, is transport. This string ID actually is good candidate to be final. And when you make it, of course, we get compilation error because setter do not work anymore, so you cannot reset it. You can set it only during construction time here, and I do not know will it work or not. Because maybe this setter is still used. So, don't think that all these examples are ideal from different perspectives. These just show you highlight these particular concepts what you need to learn for particular exercises. And here is another example about final object, and this particular case it's about collection, but I will skip it for now because we will talk about collections in more details in later session. And now about my topic for today, abstract classes and interfaces. So here we have UML diagram which shows following things. These large rectangles with small rectangles as the tabs here emulate real folders in your shelf, and these are packages. So you can put package inside package, of course, and we have some system which has shipping package, and inside shipping package is report package and domain package. And then in domain package, and domain, what this name means? It means business domain or classes which are related to particular unique business for particular management system. We have company, and these smaller rectangles are UML classes. You have company which has several vehicles as a fleet for it, and these vehicles are either truck or river barges. And shipping mine class uses company, and fuel needs report uses company, and you shouldn't be surprised that this is somehow similar business with which you dealt yesterday. Only difference is particular names and particular details. And as far as I remember, this example comes from UML standard. And problem here is that in this particular case, and what I told you yesterday is that, for example, if you have trucks and river barges, then you shouldn't actually have objects with vehicle type precisely, because this is abstraction or common structures and behavior for actual trucks and actual river barges. And what do? You create vehicle class abstract, and in such class you can declare variables, you can declare methods and implement them, but you will never be allowed to create instances or in jargon objects out of this class, because it will not be allowed. And when you extend this abstract class to trucks and river barges, then here you implement only actual differences between this abstract transport or fleet and this concrete transport, and so then your actual objects or instance created always will be precise type of trucks or precise types of river barges. And such approach is used quite a lot. And here you see why it's called abstraction, because it's abstract class, and you never find such instances in real life, but you can put some common things together here to make your code shorter and less redundant. And in Java, that would look like this. You create public abstract class vehicle, and then you create public class truck which extends vehicle, and river barge which extends vehicle. So here you put some common methods for them, and in this case these methods are just declared and doesn't have any body. But here you actually implement these methods, you override them, but because here they didn't have any bodies, these are just declarations in this abstract class, there's nothing to override. You actually implement these methods concretely for one class and another. And that's about abstract classes. Now about interfaces. From theoretical perspective and from design perspective and UML perspective, interface is public abstract class, and that means it is available from everywhere. You cannot actually create instance of this particular type, and you need to extend them, and only then you can use them. But if you look on practical terms, then interface is something completely different, because its role, how it's used, is completely different. And role is to create access points in your application or your system, how you can use some particular parts of the system. And in real world, interfaces is something like electricity sockets in your wall. It is very good physical interface because it's standardized and it delivers what it is expected to deliver. If you can plug into this socket, you will get electricity out of there. And similarly for interfaces, these interfaces are joining points between different parts of the system. And if this interface is standardized and you know how to use it, then you can use it. And what are specific properties of interface? Interface can be declared only as a public. If you have some variables inside body of interface, these are something like global constants. They implicitly are public static final, and that means that if it's primitive type, it's constant. If it's not primitive type, then it cannot be reinitialized. It still may be changing. And general syntax is public interface name and extends. So interface still may extend other interfaces. That means there may be some more general interface and more specific interfaces. About that we will talk in details, for example, when we will talk about collections later. And here is example. So why for practitioners interface is something completely different than public abstract class? Because instead of class or abstract class, you write interface keyword here. So for practitioner, of course, there is huge difference. Do you write public abstract class flyer or public interface flyer? And then you mentioned in most of cases different methods. Sometimes you can also declare some public final values as global constants. And then you do not extend interfaces. If you extend interface, you still create another interface. But for concrete classes, you implement these interfaces. So huge difference for practitioners, because you create interface, not abstract class, and you do not extend abstract class, but you implement abstract class, or in this case, implement interface. And then when you implement interface, here, these methods usually do not have body, and then you create body for these classes and implement as you like. And here is UML class diagram. And so in general this is abstract class, but you add this so-called tag or profile to this class, that this abstract class is actually interface, and then you implement it, and this is just a dependency. You may add implements, description as a keyword for this dependency, and then you implement it in concrete class. And here is another class diagram which shows different classes and interface, and interface can be implemented by different classes, and these methods inside the interfaces are called virtual methods because actual implementation will depend how exactly these declared classes will be implemented inside interface. Now more details about more modern versions of Java. And in normal old school Java, interface methods never have bodies. These are just abstract methods, and you implement them and you somehow implement them, and for debugging purpose you just print out when these are called. But starting with Java 8, I think, decided to implement some parts of functional programming. They implemented so-called introduce default methods, and then you may have default implementation inside body of this particular method, and then you can still override it So here I use polymorphism. A variable is type of interface, but actually because it is abstract class I cannot create instance out of it, and I create actual implementation as a implementation class. And if I override this default implementation, then I got this overridden implementation. If I do not override, I get this default implementation. And usually you have to implement everything from particular interface, and you can implement more than one interface at once. And when you need to implement something, here you see that you can implement several interfaces at once with the same method, because here is signature void m1 and here is signature void m1, but because they do not have bodies, you have implemented both interfaces at once with only this one single method. So you can implement more than one interface at once, and now you can form to both interfaces. But if one of this is default, and if you have overridden it, so you have this implementation, but if you do not but you need to implement it for other interface. Maybe it will work if you will call E1. But how can we call it? So that's about default. Another thing, you may think that you always have to implement everything, but it is just wrong thinking, because one of the things what you can do is you can implement only some part for it. And let's make this again not default but standard method. So you need to implement everything if your class is concrete, but if you say public abstract class, then you can implement only some part of this interface. And then you can create a concrete class and implement remaining part. Oh, you can call it, let's say call it this. And then one implementation comes from concrete class and another implementation comes from abstract class. So that's about these things. And interfaces are used to expose some part of your system and describe common behavior, how this may be working. And because normal interfaces do not have implementations, then you do not have this diamond problem. Because you do not have implemented methods. But you still have this diamond problem if you start doing default implementations. Because then you are back to this diamond problem, because you do not know what to do with this M1 method, because one have default implementation and another have default implementation, and I do not know what is happening. But if you override it again, but you can still override and use one of So if you now rely only on default implementations, you still have compilation error because of this ambiguity. but if you override them again, then you are done. So that's about thing. And here is this previous problem we dealt with yesterday, our diamond problem about our amphibia thing. So proper way to do this, there are several ways, but one of proper way is that instead of dealing with this diamond problem, your amphibia implements shark interface and human interface, and maybe it even implements animal interface. And then you can implement these interfaces easily together, because normally they would not have any bodies here, and if these are default methods, you still need to override them as you like, and then you create it in such way that move method swims in water and walks on ground. But because our requirements were different, of course, we were not allowed to use interface. We dealt with this a little bit differently. And when you implement interfaces, again, you need to remember this funneling principle, that if you have some interface and some method, let's say and let's say and then you implement then nothing bad will happen if you will implement this particular method in following way: string m1 object signature is completely different, but it will be considered implementation of this particular method, because here is input of your method, and here more narrower input is made as a more wide input, and what is output here is as a more wide one, but you made as a more narrow input. So remember about this funnel. Input in this case is string and output is object for interface, but you made it that input is wider and output is narrower. So you created object as an input and string as output, and it still fits into this agreed interface. And it is not a regular thing when you see this, but it may happen. So the actual implementation is a little bit different signatures, because you accept something more and provide something less or more narrow type. Usually it happens when you need to implement several interfaces at once, and you make your method in such ways that it can fulfill requirements from different interfaces with one method. And then what you need to remember is that for beginners it may look like that interfaces are more elastic approach than classes and abstract classes, because you can implement several interfaces at once. You can implement partial interface if your class is abstract, etc. But remember that encapsulation rule, that to make your application or system in general robust, you should hide as much as possible, because everything what is hidden cannot be abused and cannot be broken, etc. But interface is public class, so every time you create some another interface, you create some another entry point inside your system, and interfaces in general violates encapsulation principle. You expose to entire world some part of your system. So every time you create interface, you should create this only when you actually want to expose some part of your system to entire world. And by entire world I mean all other classes, all other libraries, etc. And other thing is that interfaces are abstract classes, so you cannot create direct instances out of these interfaces. And that means that every time you actually use this interface, for example, you can use this interface E1, but you cannot say new I here because it's abstract class. You need to search which class actually implements this interface, and in this case it's easy to see it's the impl class. In more tricky cases, searching which class may be more complicated because you do not have documentation. And for example, we will talk in details later, but let's search for proper Java version, even though in this case not much has changed. So collection is an interface, and you can use it as a common denominator or common factor for many implementations or classes, but you cannot use it directly. If you have good documentation, you search for this interface and then you search for all knowing implementing classes, and here they are. But if you cannot find these all known implementing classes, then of course you are out of luck. So you know this is interface, but you don't know how exactly it may be used with concrete class which implements this interface. Other thing is that sometimes you probably get used to it that you usually create new objects explicitly with new keyword and constructor. But in some cases it may be that I implementation is private. Sometimes you may have something like this. And you know interface, and you know implementing class, and you try to use it and you are out of luck again, because there is no such constructor. Again, if you have documentation and you know, then you understand that in this particular case, instead of explicit constructor, you do something like this. And you don't see explicit constructor here, but of course it runs in the same way. And such approach is called, there is one of these patterns, which is called factory method. And why it's used in a such way? Because now if we completely change implementation to something else, refactoring is much easier. We do not need to rewrite many other things because we still just use some kind of method here. So no new keyword, no explicit constructor is shown here. And this is other way how you can create new instances of particular class. So no public constructor, but there is method. And then you see that this construction is only inside this particular class, but here you do not construct anything explicitly. And again, this is easy if you have documentation. For example, you look on some implementing class. I think it will not be true for such classes, because usually they have, but if you do not have constructors, then you look on all methods and check which method returns type of your object. For example, like this one. As list is also something like this factory method, because you can create this object by not explicitly using constructor, but some other method. And so that are some tricks about interfaces. And then it may also be needed in your practical exercise about some other things. First, about wrapper classes. And wrapper classes are classes which wraps primitive types into objects. And for example, you have primitive type boolean, but boolean with capital B is a class which has boolean inside it. So if you have primitive type, then everything you need is just 1 byte, where only 1 bit is actually used to store true or false. And of course, if you need to do some optimization, you can use bit set to index these bits and use them something like an array for particular place, but if you do not use bit set because of how memory management is working, you cannot address usually smaller amounts of memory than 1 byte. But problem with such type is that you do not have methods for them, and when you just get this data 1 byte, you do not know precise type. Is it boolean or is it byte? It is just 1 byte in length, and therefore you can wrap it inside boolean class. And when you create instance of this boolean class, of course you have actual reference to it, which refers and which says I'm boolean object. And when you look what is in definition of the boolean class, of course you see that there is primitive boolean inside it. And then you have this reference to boolean class, where you have internal properties described and methods. Many methods here. And then actual value is 1 byte here to hold true or false. And similarly to all other things. So for this object-oriented wrapper classes, they have this one primitive field inside them, but they also have additional useful methods for them, and you know what proper type is, and probably if we go back to some test. And go to definition here. So here is actual field to store this value for this boolean class, but you see here that it also has static public constants, for example true and false as the names for keywords. It is serializable. We talk about serializability later. And you can parse, and so you have very many different kind of other methods in this object-oriented class. And when these things are used, in many cases these things are used to exchange data, to be sure that you have not mixed up some data types with the same lengths, like integer with float and long with double, or boolean with byte. And other thing is that it is used quite a lot in different kind of libraries and frameworks, because if everything is an object, you can always generate source code with object.property, object.method, etc. So code generation is much easier for you. And also wrapper classes may be used as an abstraction between different kind of numbers. For example, you can use integer class to deal, for example, with and convert easier from integers to longs and back. Because of these things that when you define class, you define not only structures, but you also define methods how to deal with these data structures. And other thing, what is not needed in your practical exercise but to remember is that usually you create as many classes as many Java files you have in your project. But sometimes for some design decisions you may create more classes than you have Java files, because you can declare class inside class. And when do you do this? A typical example is that if you do object-oriented design properly, every time you need to deal with structured data, you need to create class. For example, you have some editor and you need to get coordinates for x and y, when x is horizontal axis, y vertical axis for some point. And these are two integer numbers. And you need to implement something like get chords. And question is, what is return type here? Non-object oriented approach is, okay, we need two numbers. It cannot be integer, but it can be array of integers, something like this. And then you hopefully return array with just two cells, and you assume that zeroth cell is x and first cell is y. But problem is that here, again, this array do not limit you properly. It may be more than just two cells in size, and something may be mixed up that zeroth cell is y and first cell is x coordinates. So it may work, but it's quite error prone. And proper way to do is like create class codes, and you declare that inside it is integer x and integer y. And your returned type is chords. Get chords. And this is proper object-oriented approach, and you will definitely know that property x holds x value and property y holds y value. No more values, no less values, everything will be fine. And with more modern Java, actually this may not be class, but record. And int x and int y. And where is difference for record class, you don't need to have this boilerplate code for getters and setters. These methods will be generated for you automatically. But still, it is separate class, even though in this case it's not class, it's a thing called record. And then question arises where you declare this class. If you need to use these coordinates very often in many places, of course, it belongs to one separate file and you can import it and use everywhere you like. But if these coordinates are needed only inside other class and they do not have any good meaning for everything else, then you declare this class inside other class. You do encapsulation again, because every time you encapsulate something, it cannot be broken, it cannot be abused from outside world. And this is one of good reasons for such classes. And sometimes you may also create these classes static, because here, if you need to get new instances for many different points and objects, of course you will create new instances of coordinates for many points. But if similarly you need to return something without knowing of okay, so you have some window and you need to return size. And of course for each one window size is only 1. But if you create some kind of method for them, first you need to create instance for this thing. Okay, let's say new size, and then something like size is new size, size is new size, and then s get size. And sooner or later you may get tired of it because you all need only one size for one window. Then you can create this class as a static and size, and then static method get size, and then you use it like just size get size. You refer to the class and you refer to static method of this class, so you don't need this part of construction. Again, some schools of thought say that you should minimize static structures as much as possible because they take virtual memory, but I as a practitioner think that cleaner and more maintain, because I maintain systems more than I develop them, I think that maintenance is more important than splitting hairs and saving some bytes inside virtual memory. And such internal static, so they may not be internal. For example, there is class called math in Java, and it is not internal class, but it is static class. And you can always do something like math p. I doesn't like it. And so I don't need to construct an instance of math class, but I just refer to some property for it. And you see here, static, 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 but if you create internal class, you also need to say static to the class itself for compiler to know that this class should always be available to your needs. And that's also it about inner classes. Any questions or comments so far?